Hello everyone, this is Prashanth, Institute of Aeronautical Engineering, Hyderabad. I'm going to explain in terms of in the part of IoT protocols in the last session. I discussed up to the last session IoT protocols in that link layer. IoT protocols, we are dealing with IoT protocols with different protocols like application layer, session layer. In that link layer also one of the layer. So in the link layer we have different types of protocols like 802.3 Ethernet, 802.11 Wi-Fi, 802.15 802. Ethernet, 802.115, 802.16 WiMAX. So these are the three IoT protocols we discussed up to the last session. Now we are moving to the another layer, that is 802.15.4 low rate wireless personal area network. So let's move on to the so every layer having some specifications in order to develop the networks, some advantages, some disadvantages, some applications. Based on the applications we are developing some smart world which different protocols using different IoT devices. These are the things we discussed up to the last session. So now we move on to the last protocol in the link layer, that is 802.15.4 low rate wireless personal area network. So first moving to the introduction of 802.15.4 LR WPAN low rate wireless personal area network. So it is a technical standard which defines the operation of low rate. It stands for low rate wireless personal area network, that is LR-WPAN. So next move on to it specifies which type of layers from the OSA reference model. So it deals with the physical layer and medium access layer for low rate bands and is maintained by IEEE 802.15 working group only. So which defined in standard that is in 2003, which are developed or which are defined in the year of 2003. Next 802.15.4 is a low cost, then low data rates wireless access technology for devices that are operated or work on batteries. So these are the some basic points of IEEE 802.15.4, that is low rate wireless personal area network. So next move on to the WPAN low rate WPAN features. So here what are the features of WPAN LR low PAN? It is a real-time sustainability reservation of guaranteed time slots. So before transmitting the signals or before transmitting the process, so we have to divide it into the overall time divided into some time slots. So within the time slot only we can transmit the signals. So based on the time slots we can transmit the signals as per our requirement. So here real-time sustainability by reservation of first we have to define some time slots in order to transmit the signals from the transmitter. So here it supposed guaranteed time slot, that is GTS. Next future collision avoidance through the CSMA CA. So here compulsory without multiplexing we can transmit to more number of signals can pass through channels, it is okay. But at some times there may be a chance of collision, then nothing but interference. So in order to overcome that we use, so in LR-WPAN also that avoidance can be eliminated. So this is one of the feature of LR-WPAN. Next, integrated support for secure communication. So overall security it will provide for us LR-WPAN. Next one, power management functions such as link speed, quality and energy detection. So power management system, power consumption is very low when you using IoT device through the link layer. So and quality and speed also will be efficient. Next, support for time data rate sensitive applications because of its ability to operate either in CSMA or TDMA access mode. So it support for multiplexing techniques, either TDM, FDM, WDM, OFDM like that. So it support for multiple access techniques also multiple access modes also, like TDMA, FDMA, like that. It support for multiple access technique, time division, multiple access, frequency division, multiple access, like that. So the TDMA mode operation is supported via guaranteed time slot feature of the standard. So TDMA time division. So the entire time slot divided into time as per our requirement time slot. So for example, the channels are available is 4. So there is a 100 millisecond time slot. So the 100 millisecond time can be divided with 4. That is each time slot divided into 25 milliseconds. So 25 milliseconds, within the 25 milliseconds some of the signals can be transmitted. So remaining 25 seconds can be some more signals can pass through. Remaining 75, 25. So the 100 overall 100 milliseconds can be divided into some parts. So that is time division. So next, IEEE 802.15.4 conformant devices may use one of 3 possible frequency bands like 868, 915 and 2450 megahertz. So these are the frequency band of operations of LR WPAN protocol. So these are the some important features of IEEE 802.15.4 low rate wireless personal area network. So first of all, it support for guaranteed time slots. Second one, it can avoid collision avoidance. Next one, it support for secure communication in the entire digital communication. Next, power management functions such as speed, quality and energy detection also it can support. So these are the it can also support for multiple access techniques, and 3 defined frequency bands it can support, like 868 and 915 and 2450 megahertz. So next, move on to the some more properties of LRWPAN here. Standardization and alliances. These are the features are supported layers also. So physical layer is one of the layer, MAC layer is one of the layer. So what is standardization and alliances? So here it specifies low data rate physical and MAC layer requirements for wireless personal area network. So here it specifies low data rate physical layer as well as MAC layer requirements also comes under wireless LR WPAN. Next, what is physical layer? Physical layer standards enables a wide range of physical options in ISM, International Submitted bands ranging from 2.4 GHz to sub-gigahertz frequencies. Next, 802.15.4 enables data transmission speeds up to 20 kilobytes per second and 40 kilobits per second, 100 kilobytes per second and 250 kilobits per second. It having different transmission speeds like 20 kbps, 40, 100 and 250 bits per second. Next, MAC layer, it provides links to physical channel by determining that devices in same region will share the assigned frequencies only. The schedule and operating of data packets are also managed at this layer. So these are the some more features of LR WPAN, like standardization and alliances. Physical layer along with different transmission speeds we have, that is 20 kbps, 40 kbps, 100 kbps and 250 kbps along with MAC layer. So these are the some features of LRPAN. Next, some more properties of MAC layer functions here. So becoming the devices for operating as controllers in the network, used to associate and deassociate PANs with the help of IoT devices. Next, the safety of the device is very sufficient. Next, consistent communication between 2 MAC devices that are in a peer-to-peer relation. So in order to develop the relationship in between the devices, we use here MAC devices. Next, several established frame types are used by the MAC layer that accomplish above the functions. So in order to establish frame types, different frame types. So we accomplished above features like associate and deassociate PANs with the help of devices, the safety of the devices. We can provide sufficient secure functions. Next to 802.15.4, there are 4 different types of MAC frames. So here the frames are, first one, frame of data. So either maybe the data is in a random manner or any other manner. First we have to fit into one certain frame of data. Next one, frame of beacon, frame of acknowledgement. After submitting, we are getting some acknowledgement. Next, frame of MAC commands also. So these are the basic important frames of MAC which is supported by IoT devices. So almost among all 4 devices we may use to develop the communication in IoT devices. So these are the some more features of MAC layer along with the frame, different types of frames. Next, move on to the properties of some more properties of LRWPAN, topology, security, and competitive technology here. So topology, which type of topology it may support? Either maybe star. We have different topologies in our communication. Star, mesh topology, ring topology, like that we have. So in that, network based actively 802.15.4 can be developed in a star, peer-to-peer, or mesh topology. Mesh networks connect to a large number of nodes. So particularly low rate wireless personal area network can be supported in star, peer-to-peer, or mesh topology. So these 2 topologies can be supported by LRWPAN. Next, in terms of security, for data security, standard employs in advanced AES, advanced encryption standard, with a 128-bit key length as a basic encryption technique. So before submitting the or before transmitting the some signals, we have to encrypt the data. So the mode of storage or it may be changed. We have to create certain input code for encryption. So that is the one of the security feature that is advanced encryption standard. Next one, competitive technologies here. So physical and MAC layer serve as a basis for variety of networking profiles that operate in different IoT access scenarios. So these are the some more main features of properties of LRWPAN. Topology, which type of topology it can support it, and which type of security it can provide, and which type of layers it can support. That is nothing but competitive technologies. In terms of OSI layer, that is physical layer and MAC layer are serves as a basis for variety of networking profiles to operate in different IoT access devices or scenarios. Next, move on to the basic architecture of 802.15.4 LRWPAN. So every protocols are having some separate architecture. So LRWPAN also it having, so it is the upper layer in the top 2 or bottom is upper layers. In the here we have 2 main blocks here. So in the first one, upper layer 802.2 logical link layer, beyond that convergent sublayers. Apart from that, we have 802.15.4. In that we have 2 sublayers, that is MAC layer and physical layer. We already know. So in the previous slide only we have studied physical layer and MAC layer can be supported by LRWPAN. So here medium access control and physical layer. So this is the complete architecture of 802.15.4 LRWPAN. So here what are the functions of layers? It provides data transmission service. It also provides an interface to the physical layer management entity, which offers access to every physical layer management functions and missions, maintains a database of information on related personal area network. So it contains some data in terms of any other modes. It manage whole the process for a data transmission service. Next, what is the function of medium access control? MAC. It enables transmission of MAC frames. We have different types of MAC frames, like studied in the previous slide. Frames through the use of physical channel. So this is the complete architecture of MAC 802.15.4 LRWPAN. So next, move on to the what are the advantages of IEEE 802.15.4. So we have some of advantages here. Cheap cost compared to previous protocol. It is very cheap cost. Nearly 1,000 to 200 for single bit. So long battery life. Power consumption also very less. We already studied in the future. It is one of the future of IEEE 802.15.4. Next, quick installation. So it may take less time to install in the IoT device. Simple and very easy, and extensible protocol stack. So these are the 5 advantages of 802.15.4 LRWPAN. Cheap cost, long battery life, quick installation, simple and extensible protocol stack. So these are the advantages. Parallelly, we have disadvantages also. So IEEE 80 causes interference and multipath fading. This is little bit based on the communication channel. So it causes some interference and multipath fading also. So interference, co-channel interference, like that we have different types of interferences we have that is studied in the cellular communication system. So it does not employ a frequency hopping approach. Frequency hopping approach, it means frequency hopping spectrum, like that. So if in case it approaches frequency hopping spectrum or DSSS, direct sequence spectrum also, it does not approach. If in case it approaches these two spectrum techniques, it can avoid the communication may easily process. Next, unbounded latency and interference susceptibility. So these are the 4 disadvantages of 802.15.4 LRWPAN. It causes some little bit interference and multipath fading. It does not approach to frequency hopping approach. If in case it is approach to frequency hopping spectrum and direct sequence spectrum, the communication process is too different. Next, unbounded latency. Latency is nothing but different data transmitted through the entire network. Next, interference susceptibility. So these are the different advantages. Next, applications of IEEE 802.15.4. So here I mentioned 4 types of applications here. Wireless sensor network in the industry. It is used in the wireless sensor networks in the industry. Next, building and home automation. So we use building and home automation. So this is one of the application of IoT. Building and home automation. So we have different types of home appliances like fan, tube, fridge, washing machine, like that. So remote control and interacting toys. So for example, fan, ceiling fan is there. So the ceiling fan can be remote with operate with remote. So remote control fan. Next, automotive networks. So these are the 4 applications of 15.4. It is used in wireless sensor network, building and home automation, remote control and interacting toys, and automated networks. Next, applications of the last one, the first one. In link layer, we have different types of protocols. 802.3 Ethernet, 802.15.11 Wi-Fi, 802.16 WiMAX, 802.15.4 LRWPAN. So the last one is 2G, 3G, 4G mobile communication. So 2G, 3G, 3G, 4G mobile communication, second generation, third generation, fourth generation mobile communication. So what are the differences between among them all? So 2G, 3G, 4G mobile communication data starts from 9.4 kbps to 9.0 kbps for 2G, 100 mbps for 4G, and different generations of mobile communication standard, including second generation, third generation, and fourth generation. Since the introduction of first commercial mobile phone in 1983 by Motorola, we already know mobile technology has come a long way. So, being technology, protocols, service offered, and speed changes in mobile telephony have been regarded as generation of mobile communication. So, the service protocols, services offered, and speed and changes in mobile technology, step by step it will improve. Here he will discuss the features of these generations that differentiate it from the previous generations. Let's move on to first 1G technology. So it is very basic first generation technology. It uses 1G refers first generation wireless communication where analog signals were used to transmit the data. So there is no introduction of digital communication. So analog communication signals we may use here. So there is no introduction of digital communication. So the everything in a way analogous way. It was introduced in US in the early 1980s, designed exclusively for voice communication. Some characteristics for 1G communication is it up to 2.4 kbps. The speed very low, that is speed up to 2.4 kbps. Next, poor voice quality. Next, large phones with limited battery life. So the next, no data security. So these are the some features of some characteristic features or applications, whatever it may be. So the 1G technology having low speed, that is up to 2.4 kbps only. Next, poor voice quality. So in some places there is no mobile will work. Next, large phones with limited battery life. So the look like the phone is very big, but the battery life is very half an hour, 1 hour, or a half day, like that. But nowadays we have, once you fill the 100% battery, it will come up to 1 day or 2 day, like that. So we are in 2020. No data security. So some cyber security also will very high in order to hack the data. So this is about 1G mobile technology. Next is 2G. Second generation mobile telephony which uses digital signals. So the analog signals can be transformed into some digital technology, digital signals. So for the first time it was launched in Finland in 1991 using GSM technology, Global System for Mobile Communication, that is US based. Some prominent characteristics of 2G: data speed up to 64 kbps. So 2.4 kbps to 64 kbps. So we improved in speed first. Next, text and multimedia messaging possible. So hi, hello everyone, what are you doing, like that. We have to text some message through the GSM mobiles. Next, better quality than 1G. So compulsory we need we have some improvement in the 2G. So when GPRS, Global System General Packet Radio Service technology was introduced, it enables web browsing, email services, upload and download, that is up to 2.5 gigahertz. So in the 2G, just we play with web browsing, emails, sending information, receiving information, like that. The GPR is also referred as 2.5 gigahertz. So this is about 2G technology. Next, 3G. So in the 3G we have some more advantages. Data speed up to 144 to 2 Mbps. So the data kbps transformed into Mbps. Next, high speed browsing. Running web applications like video conferencing, multimedia emails like that. So up to 2G there is no video calls. But in 3G we have some video calls, video conferencing, multimedia, emails like etc. Next, fast and easy transfer of audio and video files. Next, 3D gaming also comes under in 3D. This is a cellular communication network topology using smartphones. So the 3G mobile telephony began with the start of new millennium and offered major advantages over previous generations. We already know. So in terms the speed Mbps transformed into kbps transformed into Mbps, high speed web browsing, video conferencing, multimedia, emails, new fast and easy transfer of audio video files, and 3D gaming also it came. So this is about 3G technology. Next, 4G. We already know in the 2017 only the 4G technology came into force through the Geo. Okay, so with the smartphones keeping up the trend of new mobile generation every decade, fourth generation. We are using nowadays 4G technology. Also, in past 3 months before, the 5G technology also introduced by our PM. So that is the process in depending on the area, like metropolitan cities. Speed up to 100 Mbps to 1 gigahertz. So the Mbps transformed into Gbps. Next, mobile web access, high definition mobile TV, cloud computing, IP telephony. So we have different companies like Airtel, Vodafone, Idea, Jio like that. Starting from Jio to remaining other companies. So this is about 4G technology, speed, mobile web access, high definition mobile TV. So we have more information on 4G, but these are the some input characteristics of 4G we have to know. The entire process we don't have, we don't want right now. So these are the comparison of 1G, 3G and 4G technology. So these are the references I referred for this session. References. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.